Hey everybody, this is Mr. Appel, and today I'm going to show you how to rotate a point about another point using a compass, a straight edge, and a protractor. So you see in this example, we're going to rotate A about point X, and we're going to go 45 degrees clockwise. So clockwise is going to be this way, so I'm expecting that point A that's right there to be, over here somewhere. We're going 45 degrees this way. But we want to be a little more accurate than that. So here's what I'm going to do. I'm going to take my straight edge, and I'm going to first draw the line from point X, the thing I'm rotating it about, through point A. And really the only reason I'm doing that is to give myself an aiming point or something to make it easier to measure the angle with. Because now what I'm going to do is I'm going to measure that 45-degree angle. So I'm going to take my protractor. Now I put the center of my protractor, the center meaning where that bottom line and that middle line come together. Your protractor may look a little different, but that's what you want. And I'm going to turn it so that my 0 on the protractor lines up with that line. So that's how I know I'm starting it at just the right place. And then what you're going to do is you're just going to find that 45-degree mark, which I see here, this is 0, so that's 10, 20, 30, 40. 45 is right there in the middle. And I'm just going to make a little mark out there as an aiming point. So I know if I start at X and I go through that point, that I'm going to go, that's 45 degrees from where I started. Okay, so now I'm going to move my protractor out of the way. I don't need that anymore. Now I'm going to go ahead and put my ruler. This is actually easier for you to do than it is for me on my little smartboard tool here. And I'm just going to draw the line, starting again at point X, right through that point. I'm going to extend it way off, way more than I actually need. And you'll see why we're doing that in a minute. So what you should see here is I've now done this part of the construction. I've done the 45-degree clockwise turn. So you see that's 45 degrees. The other piece that I need is I need to make sure that the distance from X to A is the same as the rotated point. Because the rotated point, it's kind of like it's on a string, so it should stay the same distance away from X. Well, that's where our trusty compass comes in, because the compass allows us to find points that are equidistant. So I'm going to put the center of my compass on my center point. I'm going to measure, and when I say measure, I'm not actually measuring the actual length, like I'm not measuring how many inches, but I'm opening my compass up. So I put the center on X, and I'm going to put the tip of the pen, or the pencil, sorry, on A, and then I'm going to mark that, and then I'm going to just extend that arc all the way through. Now I don't actually have to extend it all the way through. What I could do is just measure from X to A with my compass, and then go over here. I really just want to see where it crosses that 45-degree line. So that's actually all I need to see. But I do need you to show that on your paper. I need to see that arc, because that arc shows me that you didn't just randomly pick a point, but that you actually used your compass. So now I see my 45-degree line. I've got my distance right, so that point of intersection right there is going to be my A prime. And that is how you rotate a point about another point a given number of degrees. The problems that will get a little more challenging, I might, instead of rotating just a point, I might ask you to rotate a line segment, or a triangle, or a pentagon. All you're going to do is this same process. You're just going to repeat it for each vertex. So if it's for, let's say, a triangle, you're just going to do this 3 times, one for each vertex of that triangle. And that's all you have to know. Good luck.